Hey, this is Alpha. I am super excited to bring attention to OpenAI's latest release. As of yesterday, they announced API access to the 0.1 model. Now, before I give you the rundown, for those who are unaware or have been living under the rock, 0.1 model is a model that has taken the world by surprise. This was a release done by OpenAI earlier this year, where they showed that reasoning models or chain of thought type process outperforms the traditional processes, and I'll show you what that looks like. Today, with the announcement, I want to spotlight function calling as a feature of their latest API release, structured output, enforcing structure using tools, vision meaning ability to see and analyze images, developer messages, which is a great spin on the concept of system message, and of course you have the last piece announcement, which is the reasoning effort, whereby it's possible for a developer to enforce effort on the model while it's thinking. If we scroll down, we do see that there's some benchmarks that OpenAI shares, including that the latest release of 0.1 API access is 60% faster, and that's because it's taking fewer tokens on average. And so this is a great performance milestone that they were able to achieve thanks to their ongoing effort, and we can expect the number of tokens and the response time to decrease over time. Here they introduce a reasoning effort parameter also, whereby you can control how long the large language model thinks before answering. And of course, this is the primitive of chain of thought or thinking step by step. So the longer the model thinks step by step, the longer it takes for that model to respond. And with the reasoning effort parameter, you have an ability to control how long the model thinks. And we do see some evaluation benchmarks here for making sort of both internal tool use, internal structured outputs, as well as making some benchmarks against the industry different tests. So on the far right here, we have the 0.1 model through API access with structured output. That's where we enforce structure on the response. And you can see that across all domains, the performance is improved. And the piece that I think is important to recognize here is that they're also introducing better tiers for the 0.1 model, and they are working on it at this time, meaning they want to introduce better tiers as well as better rate limits. Now I'll dive into the 0.1 documentation first to show you what the release is about. Here we have the 0.1 model card being updated on the documentation of OpenAI. Here we have sort of a new support that includes not only text but also image inputs, quite valuable for reasoning of domains. If you are a brand in healthcare, if you're a brand in e-commerce, these are now new unlocks for you that you didn't have before. And thanks to this API access, you're able to pass in images and essentially screenshots of videos as modality for the input. And of course, you have an output modality of not only text, but also structured outputs. This is where the developers have an ability to enforce structure on the response. So that can be JSON schema, and that can be pedantic, that can be ZOD models. Regardless of the structure, you're able to enforce how the model responds back. And we have the new model cards here. So we have the 0.1 on the 17th of December, that's yesterday, you have that release. What's unique here is that the context window actually is quite substantial, and this is something that we haven't seen before. 200,000 tokens. On the previous highest was 120,000, so roughly doubling of the token count, as well as faster response. This will be quite substantial in its impact, and I anticipate that if you're a brand and you are on the sideline of using O1 with a bigger token window, it just means that you have the ability to work with bigger knowledge bases, and you have the ability to understand context better by using this model. We also have the mini being updated here. Actually, no, I am not correct. This was the previous version on the September the 12th. Again, 120,000 tokens is what we've seen up to date. And just the other piece I'll mention here, these are the input tokens and these are the output tokens. So here we have the maximum output tokens also increasing to 100,000 and from roughly 65,000. So this is also quite substantial. So again, almost doubling of a token count being used to respond. So that can be, as we've seen, very wordy responses, but that can also be something that's more long form. So for example, you can use the O1 model to do creative copywriting, and the output will be not just 1 or 2 paragraphs, but it'll be perhaps an entire article, entire research paper. If you're using this for coding, you can ask for not just a code diff, but you can also ask for the full code of your response. And if we scroll through and look at the announcement they did officially on the blog post, we do see that support for the API. Developer messages I'll briefly describe, which I haven't yet. And they also introduce some nice capabilities along with this release, including real-time API updates for the real-time communication protocol called WebRTC. And because of their multimodality, they're able to drop costs for the previous models as well. And that's quite nice, especially if you're dealing with a real-time API. And that goes hand to hand. A very quick to respond model goes nicely with a real-time API unlock. So if you are dealing with customer data and you need to deal with customers in real time, real-time API actually is quite convenient for that. You can build conversational experiences that are very real and very real-time, pun intended. Here we have the new techniques coming in as well for preference fine-tuning, as well as new SDKs for the Go and the Java communities. They're able to jump in thanks to their beta release. So up until this moment, we've seen Python and TypeScript communities really embrace AI, but as the technologies evolve, so can the ability to use these technologies. And so OpenAI is expanding their official support. So not a third-party support, but thanks to OpenAI. Here we have the O1 API in more details. We've talked about function calling. That's essentially using tools to talk to third-party APIs or external data. We've talked about structure output, where we're asking the model to respond, for example, in a JSON schema, and then we enforce that model to adhere to that schema. Quite convenient for dealing with data storage and data reliability. Here we have the developer messages. It's the instructions that we've seen from system prompts. You can define the tone, style, and behavioral sort of directives for the model to follow. Very convenient, very similar to system messages. Perhaps this can be a better way to describe system messages as opposed to as opposed to describing them as system messages. Perhaps developer messages is a better play on words here. Vision capabilities, of course, I've briefly touched on a few of these, including manufacturing, but whenever you're dealing with a screenshot of a web application or a very intricate web interface, then you can take a screenshot and you can use that screenshot as part of the text prompt and image prompt when chatting with O1 model. Low latency. This is a great way to unlock more real time. Mind you, It will not be as real-time as GPT-4o model, and that model is optimized for text completion. It doesn't have reasoning, it doesn't have chain of thought, and so this is quite important. But of course, with faster responses, you always have a benefit. I've seen individuals who spend 30-60 minutes waiting for the 01 to respond, and this will greatly improve that time. Reasoning effort is that model parameter that I mentioned at the beginning, which allows you to control how long the model is thinking. Here we have a few convenient benchmarks, which is quite nice to compare, especially to the 01 preview, meaning the previous model that was available in the API and the new model that's now available as of yesterday. So across the board, we see sort of every single capability here improve. I don't see a degradation except for perhaps factuality staying about the same. Plus or minus 2.2 as a score is not statistically significant enough to warrant kind of the previous model. Oh, my bad. This here is the new model. This is the old model. So in this case, we do see a 0.2% increase nonetheless, which is what I expect. Math, however, you do see some degradation here. And there's definitely ways to overcome that, whereby if you are more clear in the instruction, this is a one pass, meaning one shot prompt test. But if you use examples, for example, and then you're able to guide the model to think through the examples or think through in a way that leverages more modern techniques, then you're able to overcome this small variation here. So if we scroll down, we see that same flowchart as before, where you're seeing basically improvements across their technology. We do see real-time API access here, and it's quite convenient here because the WebRTC is a very standard framework. So if you are building hardware applications, if you're building browser-based applications, mobile applications, IoT devices, then the WebRTC support is quite nice. The code example here is JavaScript. Of course, this can be written in TypeScript or Python, but I think it's quite convenient. I'll show you what that looks like if I jump to the next page here. Here we have sort of new snapshots for their real-time pricing, and that changes depending on which model you're using. And beyond that, the API, the real-time API is quite convenient for real-time use cases. Fine-tuning here also introduces a new method, preference fine-tuning, PFT. It's a great variation on the supervised technique. So in a supervised technique, just for those who are not aware, you must give inputs and outputs as examples for the model. But in the preference fine-tuning, you can also give examples of good examples and bad examples. So non-preferred and preferred model outputs. And the model learns through observation what not to do and what to do more of. And of course, they believe that they will see improvement. So in this case, they had a partnership with Rogo AI, and in this case, they were able to improve performance from 75% accuracy on the base model to 80% that's been fine-tuned through this preference technique. Of course, you have the SDK releases, as I mentioned before, and beyond that, I wanted to briefly touch on a infographic I generated to be able to explain how the O1 model thinks once you have a client request, and you're able to take that model and ask for that input from a user. The user then sort of can specify just the text prompt or the image prompt. The model determines if it needs to use vision to understand, to process that. The model understands if it needs to make a function call, so this is quite convenient through the API, and that can be talking to third-party data, or it can be making internal tool calls within your own application. you execute those function calls or not. And in the end, you have, of course, the ability to use structured data. So if you're asking the model to respond in a certain way, it can apply a certain schema. If not, it just gives you back a response. And this is how you return a response. So these are the internal three components. So do you have images? Are you doing tool use? And are you enforcing structure on the response? Is what the O1 model is doing behind the scenes. I wanted to also spotlight a few posts that I saw that are quite valuable to understand the impact of the O1 model. This is something that we've seen now across other platform players in the space who wanted to match the performance of O1 and especially the techniques. So the chain of thought is the research technique that I've used myself for my clients' work. I've suggested this technique to those that I speak with, but at the same time, the Hugging Face team here, we've got Clement, who is the co-founder CEO of Hugging Face, sharing more about the work they've done on what is sort of the behind-the-scenes effort of how O1 model works like. The test time compute is the paradigm that allowed O1 to scale to offload the reasoning not on training time but on test time, meaning on the inference time. And that's how O1 has been able to scale their technology. And in this case, Clement gives a great example of what happens when you give model time to think and sort of the performance gains that are improved on that. So in this case, we see that Meta's 01B model, so that's 1 billion parameter model, it outperforms an 8 billion parameter model when it has time to think. So this is quite substantial. This is a model that's 8 times the size, and yet performance is actually better when you are able to use chain of thought. So on the left here, you see that first model, the 1 billion parameter model, improving performance and specifically accuracy, the more it's essentially thinking. And at some point, you see it actually outperforms the second line here, the 8 billion parameter line. So accuracy on this model is less than accuracy on the model that had kind of the reasoning capabilities, just like OpenAI is doing with their release. And of course, if you want to learn more about the approach that Hugging Face took, definitely check out this blog post on how it's possible to scale test time compute. The other piece I'll mention here is also another infographic, which is just to solidify the difference between asking the model to think step by step and not. In this case, you have a bigger model, so you have an 8 billion parameter model being compared to a 70 billion parameter model. This is the highest model of the family of the highest parameter model of Meta, and you can see that what happens with accuracy, if you just keep sort of using chain of thought, the performance of these models improves, and so it is quite substantial. So on this part of the 8B model, it's actually slightly stronger than an sort of guided model, which is the 70 billion parameter. So a more chain of thought model is outperforming a stronger model. So again, very powerful technique, extremely useful, not just for OpenAI, but for other language providers. And of course, there are strategies on how to do so. Hugging Face does a very deep dive on the implementation. I do wanted to mention the most important part is the simplicity of this technique, and that is, the research has shown that if you just ask the model to think step by step, and you're asking the model to respond with the solution you're looking for, that's all it takes for these models to get better. And so what happens here is that when you do this, it actually improves the model performance. Now, of course, you can get a bit more, let's say, detailed with the instructions you give it. So in this case, if you're solving a math problem, not just solving a problem. You can say, I need to solve a math problem efficiently and clearly. You can give it examples of how to respond. Use 2 or 3 steps for simple problems, 3 or more steps for complex problems. You can give it examples of what a step looks like. And of course, you can always enforce the final answer. So in this prompt, what OpenAI would consider developer prompt, you're giving much more guidance and much clearer directive to the language model to respond in the way that you expect. And this, of course, will improve the performance of that model. Now, a couple things also mentioned here is how good is the O1 really? If we look at a specific research paper that came out, this is a research paper mentioned by